We all want to breathe healthy air where we live and work. But since we can't see most air pollutants, ensuring good indoor air quality, or IAQ, can be a challenge. This module introduces some practical things you can do to assess and improve IAQ in buildings. There are two main causes of IAQ problems: the presence of pollutants from indoor and outdoor sources, and not enough ventilation bringing in clean air. Any effective strategy to improve IAQ begins with understanding and addressing these two main issues. To address pollutants, we begin by identifying potential sources by gathering information about the activities that happen in and around a building. Then we can implement the 3 R's: remove, reduce, and remediate. Ventilation is a key part of remediation. It brings outside air into the building to flush out indoor pollutants. When there's not enough ventilation, pollutants from indoor sources build up. Having good IAQ requires adequate ventilation and making sure the system is operating correctly for the space. Of course, this assumes that we have clean outdoor air to bring in, which is not always the case. We'll come back to this soon. So, how do we determine the amount of ventilation needed and ensure a space is getting enough of it in daily operation? Every indoor space needs to be ventilated with a minimum amount of outdoor air as specified by both national standards and local codes. In California, the Building Energy Efficiency Standards, Section 120.1 on Requirements for Ventilation and Indoor Air Quality sets the amount of ventilation required for a space. The amount of ventilation depends on the building's main use, expected number of people inside, and size of the space. Bigger spaces require more ventilation, as do spaces where more people pack together. A key step in achieving good IAQ is to make sure that the heating, ventilation, and air conditioning, or HVAC system, is operating properly, efficiently, and continuously to deliver ventilation when the space is occupied. Some systems are set to turn off their fans when a desired indoor air temperature is reached. This can lead to long periods where no outside air is brought into the building, so it's important to check that automatic shutoff is not happening. Strategies for assessing ventilation vary from simple and quick to complicated and involved. This will be discussed in more detail in the training modules. Simple strategies include visual inspection of the outdoor air dampers and vents and checking that air is flowing when and where we think it should be. This can be done as simply as holding a tissue in front of a vent to see whether air is moving out of it. More complicated actions can involve the actual measurement of airflow rates and require calling in an outside specialist. It is best if these checks occur as part of a regular maintenance schedule that may also include duct cleaning and replacing filters. Speaking of filters, one great way to improve IAQ is to upgrade your HVAC filters. Filters are labeled with MERV ratings, which indicate how well the filter removes particles from the air. A higher rating means better and more removal. It's common to see MERV 8 filters used in HVAC systems, but this low MERV rating means the filter mainly removes big particles that are larger than a few micrometers in diameter. Because a lot of pollution particles are smaller, like smoke and urban smog, we recommend upgrading to at least MERV 13 filters to remove both big and small particles. Higher-rated filters also do a better job removing small respiratory particles that carry germs like bacteria and viruses. A higher filter rating can, however, put more strain on the HVAC system. So it's always important to check with a qualified person that your HVAC system can handle a higher-rated MERV filter before making a change. HVAC filters need to be periodically replaced because, over time, they get dirty from all the particles they've removed from the air, which causes them to stop working as well. Filters are usually replaced on a schedule. Some systems will allow you to measure the pressure drop across the filter to help you decide when replacement is needed. Upgrading to MERV 13 or higher filters and replacing them regularly are great ways to better clean the air, improve IAQ, and protect your health. There may also be times when the outdoor air quality is so bad, such as during wildfire events, that even MERV 13 filters are not enough to clean the incoming air, and you need to temporarily close the outdoor air damper or other outdoor air intakes and put your HVAC system in the operation mode that only recirculates indoor air. You can look up current outdoor air quality conditions in your city at airnow.gov. If you don't have an HVAC system with MERV 13 filters, or if you must shut it off completely, you should consider turning on HEPA portable air cleaners inside the room to help keep particle amounts low. Once the threat passes, remember to reopen your outdoor dampers and return your system settings to normal operation. We can also assess IAQ using pollutant sensors placed right inside a room to measure pollutant amounts in real time. Most people are already familiar with two simple types of in-room IAQ sensors: smoke detectors and carbon monoxide detectors. If one of these alarms go off, there is very clearly a problem. These days, a variety of low-cost sensors are available that allow us to measure a lot more than just smoke and carbon monoxide, and to take corrective action if needed. One particularly useful measurement to assess IAQ is the amount of carbon dioxide, or CO2, in the air when a space is occupied. This is helpful because people breathe out CO2 at known rates, meaning the amount of CO2 in an occupied room can help us know whether the room is getting enough ventilation. Because people are also the source of respiratory germs, CO2 levels also hint at the risk of respiratory disease transmission. Higher CO2 means higher risk of poor room ventilation in general. But in rare cases, it could also indicate the presence of an unventilated combustion source, such as a stove. So, if we measure high amounts of CO2 in a space, we should investigate the reasons why, and then take corrective actions like increasing ventilation. How much CO2 is too much? In general, lower is better, but there's no one-size-fits-all number. The choice will depend on things like how a space is used and how many people are in it. We can also consider whether it's flu season, or if local COVID-19 rates are high, in which case we would want to set a lower CO2 target. A potential downside of providing more ventilation than is needed is that it sometimes increases energy use and costs. Guidelines for indoor CO2 targets vary, but tend to be around 1,000 parts per million, which is a common unit of measurement for air pollutants. This is a little more than double the normal outdoor CO2 concentrations of about 425 parts per million. For example, the 2022 California Green Building (CalGreen) Code says that people must be alerted if CO2 in classrooms goes above 1,100 parts per million. Now that you understand the importance of having good indoor air quality and some IAQ basics, connections between IAQ and the transmission of respiratory diseases, and strategies for assessing and improving IAQ, we invite you to learn more of the details through the various modules. As you do, keep in mind the 3 R's for good indoor air quality: remove sources, reduce sources, and remediate the air. Together, we can make our buildings and the people in them healthier.